Electromagnetic Field and Transmission Line Guidance by Aarti Ma'am, Assistant Professor, Department of ECE. Team members are S. Praveen, A. Premnath, G. Rohit. Our topic is tools for calculating electromagnetic field and transmission line parameters. Objective to implement a program which is used to find electromagnetic field and transmission line parameter. To implement our project, we are using one programming language. The programming language is C++. The programming which consists of electromagnetic field and transmission line parameters like characteristic impedance of T or pi network, reflection coefficient, input impedance, standing wave radio, reflection, and so on.
Now, let us discuss about the implementation of our project. We are using C++ programming language to develop our project, and here we are giving 10 options for calculating electromagnetic field and transmission line parameters such as force, resistor, capacitor, characteristic impedance of T or pi network, reflection coefficient, input impedance, and so on. And based on the choices entered by the user, the following parameters will be calculated. In case 1, we are calculating force, and the formula for force is F is equal to Q1 Q2 divided by 4 pi epsilon naught into R square. And we are accepting all the values such as point charge Q1, point charge Q2, and distance. And also we are mentioning the air medium for A. If user enters A means then epsilon R value will be 1, or else we are asking for epsilon R value also. Based on the data given by the user, the following force formula will be applied and the force will be calculated. In case 2, we are going to calculate the equivalent resistance. In this case 2, we are also asking total number of resistors, and the resistors are connected in series or parallel. If the user entered yes means that means the resistors are connected in series, or else the resistors are connected in parallel, and based on the data given by the user, the equivalent resistance formula will be applied and the values will be produced. In case 3, we are going to find out the capacitance, that means equivalent capacitance. For same like resistor, we are going to ask total number of capacitors, and series or parallel. If user entered yes means the capacitors are in series or else parallel, and based on the data given by the user, the formula will be applied and the equivalent capacitance values will be produced. Now, in case 4, we are going to calculate the characteristic impedance of T or pi network. First of all, we are going to confirm whether it is T or pi network. If the user entered T means then it is said to be T network, or else it is said to be pi network, and we are asking values such as series impedance Z1, shunt impedance Z2, and based on the data given by the user, we are going to apply on the characteristic impedance formula, and we are going to produce the expected output. In case 5, we are going to calculate the reflection coefficient, that is nothing but K, and we are going to ask characteristic impedance and the value of receiver impedance. Then based on the data given by the user, the reflection coefficient formula will be applied and the values will be calculated.
Case 6. Case 6 is nothing but to find the input impedance of transmission line. To find the input impedance of transmission line, some values are required. The value of the length and the value of the characteristic impedance Z0 and the value of the receiver impedance ZR, and also the value of the propagation constant. To find the input impedance of the transmission line, the formula is nothing but Z0 into ZR plus Z0 plus tang H of Y into S divided by Z0 plus ZR into tang H of Y into S. Once if we entered all the values of input impedance of the transmission line, it will apply into the corresponding formula and it will produce the result. Case 7. Case 7 is nothing but to find the reflection factor. To find the reflection factor, the value of the input impedance is required and also the value of the receiver impedance. Once if we enter the value of the input impedance and the receiver impedance, it will apply the corresponding formula. The formula is to find the reflection factor is nothing but K equal to absolute value of 2 into square root of Zs into Zr divided by Zs plus Zr. Case 8. Case 8 is nothing but to find the reflection loss. To find the reflection loss, only one value is required. The value is nothing but the value of reflection factor. The formula for the reflection loss is nothing but log of k. Case 9. Case 9 is nothing but to find the standing wave ratio. To find the standing wave ratio, only one value is required. The value is nothing but the value of the reflection factor. Once if we enter the value of reflection factor, it will apply into the corresponding formula. The formula is used to find the standing wave ratio is nothing but 1 plus absolute value of k divided by 1 minus absolute value of k. If we once enter 1 to 9 numbers, it will produce corresponding formula and the result. Above 9 values, if we enter means it will produce the result is nothing but thank you. This program will run again and again until press enter 10. The output of the program is nothing but in compiler it will ask several options such as force, resistor, capacitors and so on. It will ask the enter the choice. If we enter the choice is phi, the phi is nothing but reflection coefficient. For reflection coefficient, the formula is used to find the reflection coefficient is the value of characteristic impedance 10 and the value of receiver impedance 15. Once if we enter the value of the characteristic impedance 10 and receiver impedance 15, it will produce the reflection coefficient equal to 0.2. In practically also we proved reflection coefficient formula is nothing but k equal to zr minus z0 divided by zr plus z0, where zr equal to 15 and also z0 equal to 10. Then the values are apply into the formula k equal to 15 minus 10 divided by 15 plus 10, k equal to 5 divided by 25. Further we cancelled it means k equal to 0.2. And also compiler program also produce reflection coefficient equal to 0.2 and also practically we proved reflection coefficient equal to 0.2. And also another output also is there. In compiler, it will ask several options such as force, resistor, capacitor and so on. And it will ask the choice. Enter the choice equal to 4. If we once enter the choice 4 means the corresponding choice 4 is nothing but characteristic impedance of TR pi network. And also it will ask the enter the TR pi network. Once if we enter T network, for T network, some details is required. The value of the receiver impedance, shunt impedance and the value of series impedance. If we enter the value of series impedance is 5 and shunt impedance is 10 and it will produce the output. The output is nothing but characteristic impedance of T network equal to 7.5 ohm. And also practically characteristic impedance of T network is nothing but ZOT equal to square root of Z1 Z2 into 1 plus Z1 divided by 4 Z2, where Z1 equal to 5 and Z2 equal to 10. The values are applied into the formula. ZOT equal to root of 5 into 10 into 1 plus 5 divided by 4 into Z2 value is nothing but 10. Further we cancel it means ZOT equal to root of 15 into 40 plus 5 divided by 40. Then ZOT equal to square root of 50 into 45 divided by 40. If we cancel it in the between inside the square bracket is nothing but ZOT equal to root of 56.25. And also find the square root of 56.25 is nothing but ZOT equal to 7.5 ohm. And also compiler it will produce the characteristic impedance of T network is nothing but 7.5 ohm. And also practically we proved characteristic impedance of T network is nothing but 7.5 ohms. This is how our program is will run and it will produce the corresponding output. Thank you.